Properties, symbols, and units. Let's first look at some terms. A property is what something is like. A symbol is a shorthand way of writing something, and a unit is a scale of measurement. We are going to look at some examples which will make these words clearer. There are 7 units which have been decided throughout the world to be called Standard International Units, or SI units. And these units can be used to derive other units. And these are the 7 properties and their units. Length, mass, time, electric current strength, temperature, mole, and luminous intensity. The units, meters, kilograms, seconds, amperes, Kelvin, mole, and candela are the standard international units. So they are the 7 units decided on internationally to be the standard that we use in physical science. So let's look at these properties and their units. Length means how long or far. The symbol for length is L, whereas the unit is M for meters. The SI unit is meters. So notice that L and M don't mean the same thing. L is like a shorthand way of writing length. Instead of having to write L-E-N-G-T-H, we just simply write L to mean length. But meters is one way in which we can measure length. There are other ways as well, for example, kilometers, centimeters, millimeters, but the standard international unit for measuring length is meters. Mass, the symbol, the shorthand way of writing mass is M. Mass means how much matter is inside a body. And the standard international unit for measuring mass is kilograms. Time's symbol is a small t, and its standard international unit is seconds. Of course, we can also measure time in things like minutes or hours, but the international unit decided on as a default unit is S, seconds. Electric current strength means the rate of flow of charge, how quickly electrons are flowing through a wire. And the symbol for that is I, whereas the unit is amperes, which we shorten as an A. Temperature means how hot or how cold something is. The symbol for temperature is capital T. Notice that the symbol for time is a small t. So you can't just use a small t and a big T as you like. You must use it in the way that's been decided on. And the standard international unit for measuring temperature is the Kelvin, which we shorten as a capital K. Now you might be more used to measuring temperature in degrees Celsius. Degrees Celsius is another unit you can use for measuring temperature, but it's just not the one that was decided on as an SI unit. Moles means how many particles. The symbol for moles is N and the unit is mole, which we shorten as MOL. But we call it mole, not mole. These 6 that I've just mentioned now, you are going to come across in the physical science that you learn in grades 10 to 12. You will probably not come across the last one, luminous intensity, but that is also an SI property, and the SI unit of that property is candela, CD. The standard international units are not the only units that we can use to measure something. We can also use derived units. For example, I said we don't only measure length in meters. It might be more appropriate to measure in millimeters or centimeters or kilometers. Here are the prefixes, some of the prefixes that we can use when we derive units. You need to memorize this list. It's very helpful. Giga is written as a capital G, and that means 1,000 million. You might have come across that with a computer's memory. You might even have a computer or maybe a hard drive which has got even more memory than a few hundred gigabytes. You might have a terabyte. Tera stands for million. That's not even on my list here, but that would be with a capital T. A short way to write 1,000 million, in other words a giga, is times 10 to the power 9. What does that mean? Look here, I've written 1,000 million out in full, and you can see that it's 1 with 9 zeros after. We can see those first 3 zeros stand for 1,000, and those last 6 for million, 1,000 million. So 10 to the power 9 is a quicker way of writing that, and that means giga. Then we can get mega. Computer memories might also be explained in megabytes. Perhaps a folder or a file might be a few megabytes. Mega means million. 1 with 6 zeros after it, or 10 to the power 6. Kilo. We often describe distance in kilometers. Like maybe the distance between Cape Town and Bloemfontein is something like 1,000 kilometers. That means 1,000 meters. 1,000 is 1 with 3 zeros afterwards, so we say times 10 to the power 3. Deci. Deci is not used so very often in common language, but we do use it in scientific language. It means tenth, 1 over 10, or 0,1. We can also write that as times 10 to the power minus 1. This 10 to the power minus 1 means inverse of 10. And you can see that 1 over 10 is the inverse of 10. Or you can think of it as the minus 1 means write a 1 and then jump the comma that sits behind the 1 backwards 1 place. And that gives you 0,1. So deci is 0,1 or tenth. Centi. Centi means hundredth. Its symbol is a small c. Hundredth means 1 over 100. In other words, 0,01, or we can write it as times 10 to the power minus 2. The minus means we invert it, and the squared means that it's 10 squared. 10 squared inverted is 1 over 10 squared, in other words, 1 over 100. Or you can see it as, take the 1 with a comma behind it and jump backwards 2 places with a comma. That gives us 0,01. Milli means 1,000th, 1 over 1,000. In other words, times 10 to the power minus 3. Micro, the symbol is the Greek letter mu, which you write sort of like a curly U, and it means a millionth. 1 over a million. In other words, times 10 to the power minus 6. Nano, 10 to the power minus 9. That means 1,000 millionth. Maybe you've heard of nanotechnology. Nanotechnology has to do with building up molecules from atoms. It's dealing with very small things, as the word nano describes. 1,000 millionth is a very small amount. Nano is very, very small. Even smaller is pico. That's a million millionth. 1 over a million. So you can see those 6 zeros stand for the first million and those 6 for the next million. 10 to the power minus 12. So if you wanted a picometer, you'd need to take a meter and divide it into a million pieces. And one of those pieces would be a picometer. That is so tiny, it's really difficult to even imagine. Even smaller than that is a femtometer. Femto means 1,000 millionth. Times 10 to the power minus 15. Let's get a bit of an idea of how big each of these values is. 1 gigameter is the distance from the Earth to the Moon 3 times. 1 megameter is about the distance from Bloemfontein to Cape Town. In other words, 1,000 kilometers. A kilometer is the height of Table Mountain. So from the sea to the top of Table Mountain, vertically is a kilometer. A meter, you probably do know, because you probably have seen a meter rule. Also, if you stretch out your hand, then from the tip of your fingers to your shoulder away from your fingers is about a meter long. A decimeter is 10 centimeters, so it's about as long as your long finger. A centimeter is about as long as your fingernail, if your fingernail is cut short. A flea is about a millimeter long. Also, if you were to take 10 strands of your hair and put them next to one another, that would make about a millimeter thick. A bacterium, which we sometimes call a germ, is a micrometer approximately in width. Also, if you were to take a piece of your hair and cut it into 100 pieces, one of those pieces would be a micrometer. So a micrometer is 1/100th of a hair thickness. A picometer is 1/25th of a hydrogen atom. Another way of understanding a picometer is 1,000 protons next to one another. A femtometer, that's 10 to the power minus 15 meters, is as wide as a proton. 500 kilometers, how do you write that in meters? And 30 centimeters, how many meters is that? Kilo means times 10 to the power 3. So 500 kilometers is 500 times 10 to the power 3 meters, which is 500,000 meters. Or we could call it 5 times 10 to the power 5 meters. Centimeters means times 10 to the power minus 2. So 30 centimeters is 30 times 10 to the power minus 2 meters, or 0,3 meters. How do you see that? 30 times 10 to the power minus 2 means 30, comma, and then we jump the comma back 2 spaces, and that gives us 0,3 meters.